morning, everyone. We'll be talking today about the anesthesia machine. The anesthesia machine, well, it is a device. It receives medical gases, mainly oxygen, nitrous oxide, and air under pressure, and accurately control the flow of each of those individual gases. Gases and vapor mixtures are continuously delivered to the common gas outlet of the machine as fresh gas flow and to the breathing patient. The parts of the anesthesia machine, we have the gas supply, the pressure gauge, pressure regulator, flow meter, vaporizer, and a common gas outlet. We will go through each one of them as a separate entity. There is also other variety feature in the anesthesia machine, example, high flow oxygen flush, pressure relief valve, and oxygen supply failure. Modern anesthetic machine or stations incorporate a breathing system within it. There are different safety features in the anesthesia machine. Color-coded pressure gauge, color-coded flow meter, an oxygen flow meter controlled by a single touch coded knob. Oxygen is the last oxygen to be added to the mixture and thus by that preventing any hypoxic mixture flowing to the patient. Oxygen concentration monitor analyzer at the end. Another safety feature is that nitrous and oxygen are connected to each other so that you cannot give nitrous oxide alone without oxygen. So whenever you raise nitrous, oxygen rises with it. And oxygen nitrous ratio monitor and controller are also safety features within the anesthesia machine. The other index is one of the main safety system is we need to avoid wrong connections. We don't want the oxygen being connected to the nitrous oxide tubing system or the opposite. So one of the first thing is the pin index safety system. El pin index safety system, it's a safety system with the tubes within the cylinders, and within the cylinders you cannot connect each oxygen cylinder has its own pin index safety system to connect with the anesthesia machine, and the nitrous oxide has its own pin index system to connect with the anesthesia machine. And we have interchangeable screws, so you cannot tie the oxygen to the oxygen tubing to the nitrous oxide cylinder or vice versa. We have the screw thread for pipelines. We also have an alarm failure for oxygen supply and a ventilator disconnection alarm. And you will always need a reserve oxygen in case of emergency. In case of failure of the pipeline, we need a backup oxygen source. You have a pressure gauge. This measures the pressure in the cylinder of pipeline or the pipeline. The pressure gauge exists for oxygen, nitrous oxide, and any other medical gases. It is mounted in the front and facing panel of the anesthesia machine. So when you look at the anesthesia machine, you're going to find a pressure gauge for oxygen, a pressure gauge for nitrous oxide, and in some machine, a pressure gauge for air. And it shows you whether what is the pressure in the pipeline or the cylinder, so you know what's taking place. The gauge is a robust, flexible coil tube, which is an oval in cross-section. It should be able to withstand the sudden high pressure when the cylinder is switched on. The tube is sealed at its inner end and connected to a needle pointer, which moves over the dial with the pressure. The other end of the tube is exposed to the gas supply. The high pressure gas causes a tube to uncoil, this is the concept of the porting gauge. The movement of the tube causes the needle pointer to move on the calibrated dial, indicating the pressure. You should always be aware that each system has its own limitation and problems in practice. And to maintain it safe, we have the following safety feature in this. Each pressure gauge is color-coded, blue for night. A pressure gauge is designed for pipeline should not be used to measure the cylinder pressure. Each one should be different because each one of them function at a different pressure ranges. If the coil tube ruptures, the gas vent from the back of the pressure gauge casings, the face of the pressure gauge is made of heavy glass as an additional safety features. So even if it ruptures from the inside, it will not blow off outside because we have a very thick glass layer. After that, you have a pressure regulating valve. A pressure regulator valve is it's a device that converts the pressure from the high pressure that's in the cylinder or the tubing to a pressure that is compatible with the anesthesia machine. They are used because the gas and vapor pressure are stored under very high pressure in the cylinder. A regulator reduces the variable central pressure to a constant, safer operating pressure at about 400 kilopascal or 4 bars, which is just below the pipeline pressure. The temperature and pressure of the cylinder content decrease with its use. The other reason or justification for this is within the cylinder itself, there is variability of pressure depending on how full it is, depending on the temperature. So we need a pressure regulator to maintain a same pressure throughout the lifespan of the cylinder. You have a regulator to also protect the anesthesia machine from those high pressure. The inside component of the anesthesia machine is calibrated and made to withstand a pressure of 4 bar or 400 kilopascal. When the high pressure from the cylinder just faces those components directly, you risk rupturing them. The component of a pressure regulator, an inlet with a filter leading to a high pressure chamber and a valve. This valve leads to a low pressure chamber and outlet. A diaphragm attached to a spring is situated in the low pressure chamber. So this is an idea of the regulator. So the high pressure inlet will raise the diaphragm, and then the pressure with the desired low pressure will come from the outlet. You control how much of that will leave based on the spring force you apply on the upper component. Gas enters the high pressure chamber and passes into the low pressure chamber via valve. The force exerted by the high pressure gas tries to close the valve. The opposing force of the diaphragm express tries to open the valve. A balance is reached between the two opposing forces. This maintains a gas flow under constant pressure of 400 kilopascal. The problems with those is that, especially with nitrous oxide, formation of ice inside the regulator can occur. If the cylinder has water vapor, this may condense and freeze as a result of the heat loss when the gas expands. The diaphragm that regulates anything can rupture, and that's why we have a relief valve usually set at 700 kilopascal are fitted downstream. So in case the diaphragm rupture or there is any malfunction causing a pressure higher than 4 kilopascal, we have another safety relief valve downstream to relieve the extra pressure at 700 kilopascal. A one-way valve is positioned within the cylinder supply line. This prevents backflow and loss of gas from the pipeline supply, should the cylinder not be connected. This moves on then to a second stage regulator and flow restrictor. The control of pipeline pressure surges can be achieved either by using a second stage pressure regulator or a flow constrictor. So after the initial regulator that drops the pressure to 4 kilopascal, as it enters the machine, it is further dropped. At lower pressure, a low pressure of 100 to 200 is achieved. If there are only flow restrictor and no regulator, the pipeline supply will adjust to the flow meter control. Then we have the one-way valve or the backflow check valves. These valves are usually placed next to the inlet of the yoke. Their function is to prevent any backflow of the gas. Once it's out, it's out. It's a unidirectional valve. And then we have the flow meter. Flow meter measures the flow rate of gas passing through them. They're individually calibrated for each gas. Calibration occurs at room temperature and atmospheric pressure. They have an accuracy of about 2.5% plus or minus. For flows above 1 liter, the unit of measuring them are liter per minute, and for flows below that, the units are 100 ml per minute. The component, it has a flow control valve, a tapered transparent plastic or glass tubing, a lightweight rotating bobbin or ball bobbin stops at either end of the tubes. So this is a picture of the flow meters, and it follows the same safety features. It's color coded. It is gas specific, and by gas specific means the one calibrated to oxygen functions with oxygen, the one calibrated to nitrous will function also with nitrous. When the needle valve is open, gas is free to enter to the tapered measuring tube. The bobbin is held floating with the tube by the gas flow passing around it. The higher the flow rate, the higher the bobbin rises within the tube. The effect of gravity on the bobbins is counteracted by the gas flow. A constant pressure difference across the bobbin exists as it flows. The clearance between the bobbin and the tube wall widens as the gas flow increases. At low rate, the clearance is longer and narrower, thus acting as a tube. Under these circumstances, the flow is laminar and a function of gas viscosity. At low flow rate, the clearance is shorter and wider, thus acting as an orifice. Here, the flow depends more on the density. The bobbin or the tube usually rotates. It may get stuck in case of there's static electricity, but that's a dysfunction. It needs to be rotating. And always read it from the top end of the tube. The safety feature, as we mentioned, they're color-coded, they're color-specific, and they are calibrated. We have an anti-hypoxic system where that under any circumstances, the oxygen concentration should be at least 25%. You cannot give 100% nitrous oxide because of the safety features. Whenever you raise the nitrous oxide, the oxygen will raise automatically with that. And the other safety feature is that oxygen is the last one to be added to the mixture at the back bar. That means if there's a breakdown in the system, oxygen will reach. It's arranged that nitrous enters the system, and then oxygen. Oxygen is the last thing. So if there's something broken in it, you're not going to get a hypoxic mixture of nitrous. Oxygen will reach. And, with time, there's inaccuracy because of static electricity, and dirt can accumulate. A flow meter are designed to be read in a vertical position, so any change in the positions will affect the accuracy. And pressure rises at the common gas outlet are transmitted back to the gas above the bobbin. This results in the drop of the level of the bobbin with an inaccurate reading. So if there is airway obstruction, you will find the bobbin fluctuating. Now everything is controlled, everything is digitalized, and very modern and new anesthesia machine. There's no actual bobbin, it's all electronic.